3.3 rules for differentiation, worked out problems. This is going to go pretty quick, just so you're aware. If you have questions, let me know. But so I'm canceling the numbers on the fly. I don't write them out if I don't have to. I did it up here, but I won't do it again. Find the horizontal tangent, so we're going to take derivative, set it equal to 0. This doesn't factor, so I'm going to use the quadratic equation, but I'm not going to show the work. So. And I don't have to do more than that, but in case you went this direction. Three decimal places. Using quadratic equation again, because this doesn't factor, I get three decimal places. All right, now let's find dy dx two different ways. Leave it, derivative plus, leave it, derivative. So let's simplify that. Root squared plus 2x plus x squared plus 1 equals 3x squared plus 2x plus 1. That's one way. Now the other way, y equals x to the third plus x squared. Yeah, plus x plus 1, and then dy dx equals 3x squared plus 2x plus 1. Either way, doesn't matter to me. Let y equal this thing, find 3 different ways, yada, yada, yada. Let's do the classic way that everybody jumps to. So dy dx equals low, derivative high, minus high, derivative low over low squared, which is 2x squared minus x squared plus 3. 2x squared minus 1x squared is x squared plus 3 over 3. That's weird how it worked out, huh? I feel like I've made a mistake. Low, d high, minus high, d low. Nope, looks good. All right. Y equals x squared plus 3, x to the negative first, dy dx equals, leave it, derivative negative 1 over x squared. This is where I lose people. So negative 1, x to the negative second, I just slapped at the bottom. I move a little bit quicker on those problems. Then I rewrite that, leave it, 2x equals negative x squared over x squared plus, no, minus 3 over x squared plus 2. So I'm sensing some mistakes here. Let me see what I got. Oh, goodness gracious. That was weird. Why did I get 3 on the bottom? Very weird. I'm going to cross it out and rewrite it. I have no idea. My brain shut down for a minute there. But hey, I'm smart enough to recognize when I screw up. Let's go x squared over x squared. And let's put them together. That's 2 minus 1 is x squared over x squared minus 3 over x squared, which is x squared. And I have messed up a negative somewhere here. Boy, finding mistakes everywhere. Negative, negative, pathetic. X squared minus 3 over x squared. One more time. Not only am I making tons of mistakes, I am not leaving myself enough space. X squared over x is x plus 3x to the negative first. Dy dx equals 1 plus negative 3 x to the negative second equals x squared over x squared plus negative 3 over x squared is x squared minus 3 over x squared. How you want to do it is entirely up to you. All right. Now, I'm actually not going to write this out every time. I'll just say use the numerical derivative on your calculator to check. And I'll just say, yes, I did, and that's that. Dy dx. Leave it. Derivative. Leave it. Derivative. I actually would like to point out that I'm doing these problems too quickly because I always make mistakes when I go that fast. Slow your brain down and walk through them one step at a time, as I showed up here. You really can't go too fast. Fortunately, I have an answer key here so I can see if I screwed up. Now, it doesn't tell me how to do this. I am personally going to go with 1 plus 5 over x minus 1 over x squared, which is 1 plus 5x to the negative first minus x to the negative second, and then dy dx negative 5x squared plus 2x to the third which is negative 5x plus 2 over x to the third. And how should I show it, Mr. T? I'm so confused. Should I do it that way? Doesn't matter. Most likely this is going to be a multiple choice question on an AP exam. And all you want to do is look at it and say, is that one of the 5 answers? No. Oh, there it is. That's one of the 5 answers. Oh, no, wait, they. Whatever. Figure it out. All right. So many different ways to do these. I used to do them the long way and say, look, you could also have, I don't do that anymore. This one, I am going to go with 1 minus x over 1 plus x squared. Low derivative of high minus high derivative of low. Watch the negative as I so eloquently showed earlier, over low squared. Two x squared minus x squared minus 2x minus 1 plus x squared. All right. Now, what about up here? If I try to do this as is, it would make me insane. Since I'm good at algebra, I can do this really quickly. dy dx equals low. And this is going to get ugly. I'm going to have to start writing small. D high minus high. D low. Over low squared. All right. Boy, this is going to be fun. Dy dx equals 2x to the third, slow the brain down, plus 3x squared, minus 6x squared, minus 9x, plus 4x, plus 6, minus, and this is really bad algebraic notation, but deal with it, 2x to the third. Plus 3x squared minus 6x squared plus 9x minus 4x plus 6. I'm going to sit here and change colors. Gone. 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 Six and 6. Oh, goodness gracious. They all cancel. There's more than one. All right. Negative 3x squared, negative 3x squared. That's negative 6x squared. That's you, that's you, that's you. Plus 12. Serious math. Warned you about this one. Shows up on all sorts of tests. Just a second. Whew, just missing part of my answer key. This is u e prime plus v u prime, which is 5 times 2 plus -1 times -3, 13. Low d high minus high d low over low squared. -1, -3, minus 5 times yeah, that can't be right. Brain cramp. 5 times 2. All over -1 squared. Which is nice because that just vanishes. Equals 3 minus 10, -7. I'm actually doing these much more deliberately, not on purpose, just it's hard. And that's definitely the way to do it. Not to just buzz through it, you'll just make mistakes. Low d high minus high d low squared is going to be 10, 5 times 2, minus, I'm just looking up here, vu prime is 3 over 5 squared, 7/25. ddx is 7v prime. I feel like I have to explain that to people because that's just going to freak them out. And they're like, it's a variable. Why doesn't it just vanish v to the first power? And yeah, I'll show you that more when we get to implicit, which is very, very soon. 7 times 2 minus 2 times 3. 20. Yeah, if you're confused by this, don't be. We'll get there. Derivative of v is v prime. You actually did it up here if you think about it. U dv dx. Oh, that's dv dx up there. But it's v to the first, and it's not v to the end, I think it's just v. What is the slope of the line tangent of the curve? X equals 3, dy dx equals 2x plus 5, dy dx, x equals 3. This is how they do it with the dy dx notation. Equals 11. What's the slope of the line? 3x minus 2y plus 12. Now I'm hinting at something called implicit differentiation, but we ain't there yet. So -2y equals -3x minus 12. Y equals 3/2 x plus 6. dy dx is 3/2. I hesitated there because I was like, all right, am I supposed to plug something in? I lost my variable. That's not uncommon. What's going on? And we're good. Find an equation for the line tangent to the curve at the given point, an equation for the whole line. So we need the actual point. We need 1 comma 1 plus 1 is 2 over 2 times 1 is 2, 1. That's the point. We need that. All right, dy dx, low, d high, minus phi d low over d low squared. Now, been doing a lot of nasty algebra. We could, but sure would be a lot easier to just plug in 1 now. Instead, x equals 1. These are all x's. Let's do that. dy dx x equals 1. 2 times 3, 6 minus 2 times 2, 4 over 4 equals 2/4 equals 1/2. Y minus 1 equals 1/2. X minus 1 plus 1. That's me being lazy, slapping the plus 1 on the other side. Mostly because that was more or less out of space. Now I need this point again. -1 comma -1/4 1 plus 2. 3 over 1 is 3. Y equals x squared plus 2x to the -2nd. dy dx equals 2x minus 4x to the -3rd. I don't have to change anything because I'm just plugging in -1, -2, minus 4 over -1 to the 3rd is -1. 2. Y minus 3 equals 2x plus 1 plus 3. Y minus 3, throw it over plus 3. Woo! Doing math. Hands starting to break here. But this is what it's all about. Just keep cranking. Time to y dx. Don't ask me why. You should be able to stop there, but for some reason, it's always going to be written as. And I'm just saying goodness gracious, in a multiple choice problem, it would not be unusual to see it this way, or even with a common denominator. But for open response, don't change it. You're just introducing the possibility of making a mistake there. So this is x to the 1/2 minus 1 over x to the 1/2 plus 1. I feel like I should multiply by a conjugate for some reason, but we'll avoid that. So dy dx low d high minus high d low squared. Whew. You have to write small. Tricky stuff here. All right. X to the -1/2 times x to the 1/2. Multiply, we add, we get x to 0, cancel, so we just get 1/2 plus 1 over 2x to the 1/2. And then on the other side, with the same thing, minus 1/2 plus, same thing, 1 over 2x to the 1/2. And we always put the square roots back in. Don't ask me why. So these are common denominator. That's just 2 of them. The 2's are going to cancel, so we're just going to bring the x to the 1/2 down. 1 plus 1 is 2. 2 over 2 cancels. 1 over square root of x times square root of x plus 1 squared. Happy you're in my class yet? Now the first four derivatives of the function. I feel like doing y primes because I haven't done them all day. Piece of cake. Notice the -1 never vanishes. Now we're going to do a lot of this when we get to infinite series. And I can't help myself. You don't have to. Can't help myself writing it with the exponent on the bottom. It's just part of my genetic makeup, I guess. I'm going to go to line perpendicular to tangent of the curve at the point 2, 3. Hey, they actually give it to us. Isn't that nice? dy dx. Yeah, I did y prime up here. That's the end of that. I'm just kidding. It doesn't really matter. 3x squared minus 3 dy dx. Now, they actually gave me a point of 2, 3. I don't think I need the parentheses over here. Never sure how they write it. It doesn't really matter that much. We only need that, of course. 3 times 4 is 12, minus 3 is 9. All right. The perpendicular. So we get y minus 3 equals -1, 9, x minus 2 minus 3 plus 3. Find the points on the curve where the tangent is parallel to the x-axis. So x-axis is horizontal. So I want where the slope is 0. Fine, I lied. I'm going to bring back y prime. 6x squared minus 6x minus 12. 6x squared minus 6x minus 12 equals 0. X squared minus x minus 2 equals 0. X minus 2, x plus 1 equals 0. X equals -1, 2. Now it said find the points. Didn't say find the x values. So it said found the points. So we really need to plug them in. -1 to the third, -2, minus 3, -5, plus 12, 7, plus 20, 27. So we get -1, 27. And again, it'll be very clear about this on an AP test. It'll say find the x value, find the y value, find the coordinates, which is a lot more clear than saying points. 2, 8 times 2 is 16. Minus 12 is 4. Minus 24 is -20, plus 20 is 0. Feel free to graph this and see if there's a peak or valley here and here. I think you'll find there is, but never a bad idea to graph it and check. Find the x and y intercepts. Line is tangent to the curve at the point -2, 8. So nice of them to give us that. Y prime equals 3x squared. X, y, line is tangent to the curve. Interesting. -2, 8. Y prime of -2 equals 3 times -2 squared equals 12. So y plus 8 equals 12, x plus 2 minus 8. All right, x and y intercepts. X-intercept, that's when the y equals 0. 0 equals 12x plus 2 minus 8. 8 over and divide by 12. 8 twelfths, which is 2/3. x plus 2, x equals 3 times 2, negative 6 plus 2, negative 4/3. Y-intercept, y equals 12 times 0 plus 2 minus 8. Y equals 24 minus 8, 16. And you might want to write them as, what is it? 0, negative 8, and no, that's wrong. Negative 8 comma 0 and 16, 8, 0 comma 16, but you don't have to. Almost there, folks. Boy, I hope you do all these problems. I really hope you do all these problems. Find the tangent to Newton's Serpentine. I don't know what Newton's Serpentine is. Yes, I do. It's the graph of that. It's pretty straightforward. Let me see if I have it memorized. I think it's going to look like this. I'm going to quickly slap it up here. And then I will show you what I did. Excuse me. So plugged it in, 4x over x squared plus 1. Graph it. Yeah, I'm wrong. By the way, why is it such a grand idea to graph these? Well, how many tangents are there going to be? On the tangent at the origin. I thought they were going to ask for these two things. I'm sure I do that another time. Find the tangent, Newton's Serpentine at the origin. And the point, 1 comma 2. I guess it doesn't say, but it means tangent line. So let's just plug that in there, line. dy dx, low, d high, minus high, d low, dy dx, x equals 0. That's the origin. 4, 4. Okay, it's at the origin. So y minus 0 equals 4x minus 0, 4x. And let's find dy dx, x comma y equals 1 comma 2. I just can't do it. I gotta have parentheses there. Equals 2 times 4, 8, minus 8. Cool. Over 4, 0. So that must be this point here. So that's just going to be y equals 2, because they gave us the 2. Cool math. Now, the Witch of Agnesia, I actually don't know what that is. And it's a mistranslation of a woman's name. And it sounds very skeevy, to put it very, very mildly, about why they're calling this woman a witch. They're not. They just mistranslated her name. Look it up. It's interesting. I was lazy, so I wrote it as x squared plus 4 instead of 4 plus x squared. But as we all know, the rule says it's okay. And the reason they call this the Witch of Agnesia, they meant to say wheel. If you put a little peg on a wheel, a small wheel that's about this diameter, and then just traced that over time, it'll go up and it'll come back down. Anyway, I think I covered that another time. Tangent to this. Okay, let's be lazy. I'm not even lazy. Let's be clever. 4 plus x squared to, oh, I can't do that. Haven't learned that yet. Soon. Y prime equals low, d high, 0 minus high, 8 d low, 2x, 4 plus x squared, squared. Tangent line. Okay, so y prime of 2, y prime, did it again, of 2 is, that's 0, 4, 8, 32, negative 32. 2 squared is 4 plus 4, 16 squared. It's a big number. Also known as negative 1, 8 times 2, 16, 18, 3, 24, 16. That's wrong. 2 squared, I went 4 times 4, 4 plus 4, 8 squared, 64. I had a feeling I screwed that up. There you go. And y minus 1 equals negative 1/2 x minus 2 minus 1 plus 1. We actually should slap that out here. This is the graph I thought Newton's Serpentine was. Something like that. It's actually smooth here. There's no cusp there. It looks like one. But it doesn't matter. They asked for that 2, 1, 1, 2. So negative slope, yep, hits about 1, yep. Good to go. Rock falls from rest. That's our next unit. Why do I do this? Oh yeah, that's right. I want to introduce you. So blah, 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 ds dt equals 9.8 t. Do we have units? Oh, we do have units. Meters per second. Yep. And then d squared s dt squared equals 9.8. This should all be negative, but we're being lazy. Meters per second squared. And this is the gravitational constant for Earth. Don't believe me? Go ask your physics teacher. Coming to a math lesson near you in the near future. Volume of sphere, what is dV/dr? Now this is where people freak, because oh my lord, there's a variable in there. Whatever shall we do? So V equals 4/3 pi r third. Is r a variable? Yeah. Bigger, smaller, bigger, smaller. So if I say dV with respect to r, I'm just saying that's now my x. It's really not a big deal. 3, and I never do this anymore. 3 out front, r squared pi equals 4 pi r squared. Hey, that's the area of a sphere. Surface area. Now, what about area and circumference of a circle? Well, area is pi r squared, dA dr is 2 pi r. Oh, that's the circumference of a circle. That's cool stuff. All those formulas have been getting jammed down your throat in geometry forever. They actually mean something. Good luck and happy mathing.